Hello, everybody. Welcome back from your academic break. I hope that for at least a week you could put down everything and not worry about any kind of academics. I know that, I'll be honest, I did. And let's get back to it. We only have 2 units left, and this is a fairly short unit. The last unit, hopefully, we can do back at school. I'm still holding out hope, but no matter what, we'll be together for it. All right, let me get rid of my face here. I wanted to say hi, miss you guys. All right, bye. All right, so our second to last unit is about sequence and series. So day one, sequences and sigma notation. We're going to do 3 concepts today, and we're going to find out what those 3 concepts are right now. So a sequence is basically an ordered list or a pattern of numbers. That's it. If you have a pattern of numbers, it's a sequence. And that pattern could be many things. Here's one pattern from 2 to 5 to 8 to 11. Notice what's the pattern there? We're adding 3. I knew it. I knew you knew that. And here's another pattern. 1, 2, 4, 8, 16, 32. What's the pattern there? We're multiplying by 2 each time. So a pattern can be found by adding, by subtracting, by multiplying, by dividing, and by doing many other things as well, by squaring things, any kind of pattern. So we're going to talk about 2 different types of pattern over the next few days. One pattern where you add and one pattern where you multiply. But in general, anything with a pattern is a sequence. Now, every sequence has a first term and a second term and a third term and a fourth term, and so on and so forth. A sub 1, A sub 2, A sub 3, A sub 4, and so on and so forth. But notice how I do sub 1, sub 2, sub 3, and sub 4. So in general, it's A sub n. And whatever comes after A sub n is what I'm simply plugging in to find. Okay, and so I'll write that down. A sub 1 represents the first term, and I apologize, that's my daughter playing with the science project next to me. A sub 2 is the second term, and A sub 3 is the third term, and so on and so forth. So look at the directions for this first section. Find the first 3 terms. So you know what that means to me? It just means do A sub 1 equals, A sub 2 equals, and A sub 3 equals. Believe it or not, to answer these questions, no joke, it is just a Glade commercial. Plug it in, plug it in. Haven't heard that in a while, have you? So 2 times 1 plus 1. 2 times 2 plus 1. And 2 times 3 plus 1. I am not joking. This is all you have to do to find the first 3 terms. Plug in 1 for the variable, plug in 2 for the variable, plug in 3. So that's 2 plus 1, which is 3. 4 plus 1, which is 5. 6 plus 1, which is 7. And you're done. I'll do one more of these with you because honestly, after that, it would get repetitive. So then I'm going to do A sub 1, A sub 2, and A sub 3. All right, so that's going to be 1 squared plus 1, 2 squared plus 1, and 3 squared plus 1. 1 squared is 1, 1 plus 1 is 2. 2 squared is 4, 4 plus 1 is 5. 3 squared is 9, 9 plus 1 is 10. There's the first 3 terms. That's it. That's all you have to do. Crazy. Concept 1, done. So part of your homework is to find the first 3 terms or the first 4 terms, so on and so forth. I'm going to skip past the rest of these. So you can also create a pattern by building off of what you just found. All right, so by building off the previous term or terms, all right, so using the previous terms in parentheses. So an example, I'll write an example of a recursive formula for a sequence. A sub n equals A sub n minus 1 plus 2. So this A sub n minus 1, that right there is the recursive part of the formula. Just think about it. If A sub n is A sub 5, n minus 1 is 5 minus 1, which is 4, so it'd be A sub 4 plus 2. Notice how A sub 4 is the term just previous to A sub 5. What if I wanted to find A sub 10? 10 minus 1 is 9, so I would do a sub 9 plus 2. Probably not the best thing to write a and then 9 right next to it, but you get my point. To find a particular term, you use the term just before, just previous to it. Find a particular term, you use the term just previous to it. So a recursive formula for a sequence requires two things. It requires a general formula, and then it requires a gift of at least the first term. So if I want to find the first 4 terms of the sequence, I already have the first term. A sub 1 is the first term. If I need to find a sub 2, I need to find a sub 3, and I need to find a sub 4. Let's do that. So this a sub n minus 1, I don't even see a sub n minus 1. You know what I see? I see previous term. So it's the previous term plus 6. It's the previous term plus 6. And it's the previous term plus 6. Okay, what's the previous term to a sub 2? Isn't it a sub 1? Right, but what is a sub 1? A sub 1 is 4. And 4 plus 6 is 10. There's my first answer. To find a sub 3, I need to take the previous term plus 6. But what's previous to a sub 3? Isn't it a sub 2? Well, wait, what is a sub 2? We just found it. A sub 2 is the 10. 10 plus 6 is 16. Done with that. To find a sub 4, I need to take the term previous to a sub 4, which is a sub 3. What is a sub 3? It is the 16. We take what we just found to help find the next thing. And 16 plus 6 is 22. And there we go. We've answered all 3 questions. I'll do another recursive formula with you. All right, so in number 10, they're giving me the general formula, general recursive formula for the sequence, and they're giving me a sub 1. So I need to find a sub 2. I need to find a sub 3. And I need to find a sub 4. The formula is 3 times the previous term. I'll do a parenthesis. 3 times the previous term plus 2. And 3 times the previous term plus 2. And 3 times the previous term plus 2. Well, again, what's previous to a sub 2? A sub 1. What is a sub 1? That's the gift. That's 5. And 15 plus 2 is 17. Then I take what I just found and I plug it in to find the next thing. 3 times 17 plus 2. And that's going to be a pretty big number right there, isn't it? By the way, you can use your calculator to find any of these. So 3 times 17 is 51. 51 plus 2 is 53. Then I take what I just found and I find it again. 3 times 53 is 159. Plus 2 is 161. People often find the most confusion right now with recursive formulas. So if you need to, pause this video and play it again as many times as you need to fully understand recursive formulas for sequences. You take what the previous term is and plug in to find the next term. And that's my daughter having some fun with the teddy bear that plays music. All right, more recursive formulas. As long as you see a sub n minus 1, that lets you know it's recursive. Number 15 basically says take the previous term and square it. So just quickly here, I'll just find a sub 2 and a sub 3 with you. So that means previous term squared. Means previous term squared. Previous to a sub 2 is a sub 1. What's a sub 1? It's 2. Squared is 4. Previous term, then I plug that previous term in to find the next term. 4 squared is 16. Hopefully you follow along how to find. The problem with a recursive formula is in order to find, say, a sub 8, you need to find a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and then you can get a sub 8. It's a pain, as my grandmother would say, in the dupa. Whereas if you just use an explicit formula for a sequence, if I want to find a sub 8, I just plug 8 in, plug it in, and get my answer. These are not recursive. You could just plug in whatever number you want to find that term. So that's the second of 3 concepts. The third and final concept is sigma notation. So seniors, next year when you get to college, you might walk down fraternity or sorority row and see a lot of Greek letters. In particular, you might see this letter. This is the capital Greek letter sigma. In math, this is the summation notation symbol. When you see this capital Greek letter sigma, it basically means to add stuff up, sum. All right, so the summation notation formula might look like this as n equals 1 up to 4 of, let's just say, n. This bottom number is called the lower limit of summation, and that's the number you begin with. And stands to reason that the top number is called the upper limit of summation. So if I see this formula, and by the way, this looks all Greek to me. I'm here all week, folks. I know, with dumb jokes. It means just take n and plug in. I'm going to start by plugging in the bottom number, so I'll plug in 1. Then it's called the summation notation symbol, sigma is, because I'm adding. And what's the next integer after 1? It's 2. You add integer by integer, so plus 3, until you get to the top number, then plus 4. But here's the thing. The answer is the sum of all these numbers. 3 plus 4 is 7, 7 plus 2 is 9, 9 plus 1 is 10. My final answer is 10. This shorthand sigma notation is just a shorthand way of writing a potentially long sum. Now from 1 to 4, not a long sum, but what if I went from 1 up to 100? This is a much shorter way of writing this long sum from 1 to 100. So why don't we do a problem, and I'll show you what I'm talking about right here. So basically, this is just algebra and plug it in. I'm going to do it over here where I have a little more space. So the sum, as n goes from 1 to 5, of 2n plus 5. I'm going to repeat that. The sum as n goes from 1 to 5 of 2n plus 5. So I'm going to start by plugging in the bottom number, which is 1. So 2 times 1 plus 5. Then integer by integer, I'm going to keep plugging in. So 2, then 3, then 4, and then finally 5. I get my answers here. 2 plus 5 is 7, 4 plus 5 is 9, 6 plus 5 is 11, 8 plus 5 is 13, and 10 plus 5 is 15. But once I get those numbers, I don't stop there. Okay, I need to add up all 5 of these numbers, add them up. And what I end up getting is my final answer of 55. Do not be the person that does all this work and getting all these sums and then just leaves them the way they are. The summation symbol means to add them up. It's really not difficult. You just plug it in, but for integers going from the bottom number to the top. I'll do one more example with you, and then we'll call it a day. All right, how about the sum as n goes from 2 to 5 of n squared? So that means I'm going to start with 2 this time. So I'll do 2 squared, and then 3 squared, and then 4 squared, and then 5 squared. I started with 2, and I went until I got up to 5. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. There's my sum. And if I do 4 plus 9 plus 16 plus 25, I get 54. That's my final answer. Okay. I'm going to, in this last example, I'm going to say the biggest mistake that gets made. People see this problem, and they'll do this. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. This is a mistake. Why is it a mistake? Because instead of starting at 2 and ending at 5, they started at 2 and then they did 5 terms. That top number does not tell you how many terms to use. It tells you where to end. You begin at 2 and you end at 5. You don't do 5 terms. I hope you understand that big mistake right there, and we're going to call it a lesson. Write me an email if you have any questions. Bye.